All right, we're going to talk about reaction types. And so the biggest thing here, I'm not going to balance them. Hopefully by now you can balance these. If not, look at them, try to balance them. Come talk to me. Come talk to any of the other chemistry teachers if you're struggling with it. Okay, so we're looking at this. We have to decide what type of reaction it is, okay? You know there's 5 different reaction types that we have, okay? So we're going to list these over here to the side. Move this over. You have synthesis. We also call this combination. Okay. You have single displacement. You have double displacement. We have combustion. And what else? One more. Oh, decomposition. All right. So those are the 5 reaction types. You guys are, no, did I put 4? 1, 2, 3, 4, 5. No, 5. Okay. So you guys already know these. And the biggest thing is you need to identify what you're looking at. So here we've got 2 reactants. We make a single product. The important thing is that there's only one thing over here on the product side. When there's only one thing on the product side, it has to be a synthesis or combination reaction, okay? Because basically you made one thing, all right? All right, let's look at this next example. You've got a single metal by itself, and it's going to, in this place, it replaces the zinc here. So aluminum comes, replaces the zinc. Zinc is kicked off by itself. So aluminum starts out being single. It's now paired up. Zinc is single on the product side. It started off being paired up. This is a single replacement. Okay, you have one thing by itself on each side. Now, the key thing is with a single replacement reaction, you have to look at your activity series, okay? You have to look at your chart in order to make sure that this reaction will actually take place. So what you're looking for is you need to see, is aluminum reactive enough to take zinc's place? So this has to be more reactive or more active than what zinc is. So if we look at it, here's aluminum and here's zinc. And so based on that, we see that aluminum, this says increasing activity. That means that aluminum is more reactive than zinc. So yes, this reaction will occur. Had it been flipped and you had zinc over here and aluminum here, you'd get no reaction. Okay. All right. So we look at our next example here. We have potassium chlorate. And in this case, we have one single reactant. That's the key to this. A single reactant, and the only thing it does is break down. And anything that breaks down, like when somebody dies or is a dead animal on the road, whatever it is, it's called decomposition, right? So this one is decomposition. Great. All right, next reaction. This is ethane gas, and we're going to react it with oxygen. We get 2 products, carbon dioxide and water. These 2 products right here keys me to what kind of reaction this is. Anytime you see carbon dioxide and water, 99% of the time you're going to get a combustion reaction. Now, the key to it is there's no you can't have a combustion reaction unless you have oxygen. So you have to have oxygen present to make something burn. You also have to have a carbon and a hydrogen. So in this case, this is going to be a combustion reaction. Okay? All right, so it's combustion. All right, this one looks like a big long mess. What you need to look at is I got silver and I got nitrate, and over here I've got silver and I've got chloride. Here I've got sodium and chloride, and now over here I've got sodium and nitrate. So it looks like what happened is this is your cation, the metal, right? And your anion, the chlorine. Those 2 end up being partners over here, and your sodium and your nitrate end up being partners. So basically it's kind of like dancing, they switch partners. All right, and make sure that you know that you always list your metal first, okay? So your cation will always be listed first. Now, when you see a double displacement reaction, the next thing you have to do is you have to go and look at your solubility chart, okay? Because you have to decide what type of reaction this is. We've already identified this as, yes, this is a double replacement, but there are multiple kinds of double replacement reactions. This one happens to be, if you notice here, I have an S. This S stands for solid, okay? All of these are going to have AQs. The AQ just means aqueous. So basically, like if this is salt, we dissolved it in water. So over here, this is aqueous. It means it's soluble. It means it's going to dissolve when you put it in the water. So let's look at our solubility chart, okay? Here we have silver and we have nitrate. So this one says that everything that's soluble, so these are solubility right here, right? If I go to my nitrate, you can see that it says, is there any exceptions? There are no exceptions. So everything with a nitrate is going to be soluble. So is silver nitrate going to be soluble? Yes, that's why it's listed as aqueous. Then we go to sodium chloride. So let's look down here. You see chlorine. All right, here's chlorine. It says that everything in chlorine is soluble. And I'll bring this up so you can see it a little better. Except for if chlorine is with silver, lead, or mercury. Well, over here, it's with sodium. That means it's soluble. That's why we put aqueous. However, we just saw on this chart, right? Chlorine with silver. That's a bad combination because what's going to happen is it's going to form a solid. So this is what happens. You mix the two clear liquids, and what you end up with is this white solid at the bottom. It kind of looks like a snow globe. And so, oops, my dad's calling. Hey, Dad, I have to call you right back. Okay, so this gives you, this is a precipitate, so it forms a solid. Over here, we just saw with the nitrates, we have nitrate, no exceptions, so everything that's with a nitrate is going to be soluble. So this right here is a solid, and if I ask you what kind of reaction this is, not only is it double displacement, but it is a precipitation reaction, or you'll see it PPT. Okay, that's a precipitation reaction. Now, we look at our next example here. I have HCl. It's combining with NaOH, sodium hydroxide. What do we see on this side? Well, my H went with the OH. So we have H with the OH. This can also be written as H2O, which is water. My chlorine and my sodium switch places. So now I have my sodium and my chlorine together. Remember, sodium always has to go first. Stop. So what we end up getting here, you see that this forms a liquid, okay? This is also going to be a double displacement reaction, but the key here, you guys remember this from naming section, right? If it starts with an H, it's probably an acid, right? If you have an OH somewhere in the problem, remember OHs are bases. So this right here, not only is it double displacement, it's also an acid base. Okay? So anytime you see an H and you see an OH, and this is on the reactant side, and you form H2O and you form a salt, and by salt, you see right here NaCl, this is an ionic compound because you have a metal and a non-metal. So anytime you form a salt and water, it's going to be an acid-base reaction. So you start with an acid plus a base, you get a salt and water. And by salt, we mean ionic compound, metal and non-metal. Okay, next one. We're almost done. We take iron and we take oxygen. We put them together. We get one product. One product means it is a synthesis reaction, or you can also call it combination, okay? The key is you get one product. All right, next one. We have lead, we have nitrate, we have sodium, we have iodine. If we look over here, we get lead iodine and we get sodium nitrate. So these two switched, these two switched. This tells me that this is a double displacement reaction. But not only is it double displacement, now we have to identify what type of double displacement. So let's go back to our chart. We have to look at our solubility chart. On the solubility chart, you see nitrate. You see nitrate. No exceptions with nitrate. Everything with nitrate is soluble. So you see here, lead nitrate, soluble. Sodium, iodine. Let's go over here. We look at iodine. Any exceptions? Yes. Anytime iodine is with a silver, a lead, a mercury, it's going to be insoluble. And by insoluble, what do we mean? We mean it's going to form a solid. So if we look over here, this is going to be soluble. But we get here a solid because remember, iodine with lead, it's going to give us a solid. So anytime we see a solid, we know that this is a precipitation reaction. So it's a double displacement and it forms a precipitate. So that's what you need to know for that. All right. And the last problem we're going to do right here for this section. We have iron and we have zinc nitrate. So remember, if we're looking at this, we got one thing by itself, okay? And so this is going to be a single replacement reaction, most likely. How do you know it's not synthesis? The reason I know it's not synthesis is because I have a metal and I have another metal. This is right here is an ionic compound because remember, it's a metal with your polyatomic ion, which is also a non-metal. So this is telling me most likely this metal is going to try to replace this metal. Question is it reactive enough to do it? Here's iron, because remember iron is Fe. It's below zinc. In order for iron to replace zinc, zinc would have to be below it. The most reactive one will replace the other one. So in this case, will iron replace the zinc? No, because the iron is below the zinc. So over here we would write no reaction. Okay, that should be it for your little bit of review on reaction types, and make sure that you know your precipitates, how they form, your activity series, and what your acid-base reactions are.